The problem was if we receive the same LSA from multiple routers, so the same router is giving us the another LSA which I have in my database, and if that is the case, which LSA I'm going to believe, right? And that is where somewhere the sequence number is going to come into picture, right? Let's have a look at it. So what is happening here, guys? We have a pretty simple topology. We have this R1, R2, R3, and R4, and we are running OSPF everywhere. And you all know that if we are running OSPF everywhere, the process will start from R1, right? And then it will start having its relationship with R4, which is the neighborship, which is going to become the adjacency here. Let's consider all of them are point-to-point link, right? Then basically R2 and R3 are going to be synchronized with itself, and then R4 and R3 are going to be synchronized. So at the end of the day, every router of this topology is going to have one piece of information, or the same piece of information, which is the link state database. It means that irrespective of the fact, irrespective of what router I am talking about, the link state database at every router is going to be same. Means if I say this green color drawing, which I am showcasing you here, is the information contained in R1 database, this is the same information you are going to see in R2, R3, and R4. Why I'm saying this? Because this complete topology have been synchronized. R1 is synchronized with R2 and R4. R4 is synchronized with R3 and R1, and R2 is synchronized with R1 and R3. It is as simple as that, right? If that is the case, and this you should know that inside an area, inside an OSPF area, every router is going to have the same or exact same database, and that is what we are seeing. So if you want to debug your complete OSPF inside an area, it doesn't matter on which router you are, and this is the interesting thing. You just need to log in into that router. You will be pretty sure that other routers are going to have the same database. This is very, very important thing, guys. Having said that, now let's see how a particular LSA look, and we have discussed about it. If we talk about R1 is connected to three links. Link number 1, 2, 3. If we talk about link number 1, this is the transit network. Why? Because it is transit between R1 and R2, and that is why we can see here. Link 1 is connected to the transit network. Link 2 is also connected to the transit network between R1 and R4. We have discussed the definition on the meaning of the transit network. And the last thing is this router is also connected to a stub network, which is your link 3. It is as simple as that. And this LSA, which we have here, right? This LSA is actually going to be advertised to R2 and then basically to R4. And from R2, it is going to be flooded to R3. And then basically from R4, it is going to be like here. It is simple. And that is why every router is going to have, every router is generating this LSA, their respective LSA, and that is why we came to know about this database. But what is the catch here? The catch here is, suppose somebody is here and his whole sole intention is to disturb your network, and he knows OSPF well. So what it is going to do is it is going to log in into this router and just shut down this interface, or maybe it is just taking the plug out of the router 1, right? The cable out of router 1, this link number 3 cable. And if that is the case, then now we do not have this link number 3, and it has to go out from the LSA. And if it has to go out from the LSA, then basically the information is changed in this LSA. Previously, R1 was sending that I have 3 links. link 1, link 2, and link 3. And this is my LSA, R1 LSA, towards whom? Towards R2 and towards R3. And that is why R2 has installed in its database that it just got R1 LSA. Right? This is the state previous to this guy. So no problems. But now we have made sure that link 3 is gone. So it means that R1 is thinking the information which I supplied, which I forwarded to R2 and R4 is not correct, right? Because there is a recent change in the information, and there is a recent change in the information, then R1 is going to send the LSA again, right? The same LSA, but with different content. Now it is going to remove this and everything is going to be same, right? Now here is a confusion. The confusion is, let me draw this LSA with the green color, right? So it is going to reach here, this R1 LSA. And previously in the R2 database, we already have the R1 LSA. Now on what basis it is decided that which one is new information? So what R1 is going to do, R1 is going to mark this LSA or every LSA, whatever it is generating, with the sequence number. And suppose the sequence number is 1000 here, right? The new sequence number is 1000. Suppose, right? It means the router has already generated this sequence number for R1 also, and maybe it was 999. So the first LSA, which is already into the database of R2, R3, and R4, is having the sequence number 999. And now, because there is a change in the information, I am sending this LSA again. R1 is sending LSA this again with the sequence number which is one more than the previous one. So previously we were sending with 999. Now we are sending the same LSA with 1000, right? And of course, if the sequence number is more, then R2 comes to know this green LSA which I recently got from R1, it is a new LSA which is 1000. It is as simple as that, right? So what it is going to do, it is going to flush out this LSA, this information, the previous information out of the database, and it is going to include R1 new LSA with the sequence number 1000. It is as simple as that. What is going to happen, guys? R2 is going to flood this information, R1 LSA, with the sequence number 1000 towards R3. It is as simple as that. Now R3 has to flush out the R1 LSA with the sequence number 99, because you know that everybody previously got the sequence number 999. Simple, right? Now, you must be thinking that Vishnu is not talking the complicated things. These are very, very simple things. Now, let's try to understand. R1 is going to advertise the same thing here, the R1 LSA with sequence number 1000. R4 is going to flush out it, right? Interesting. Now, here we have the sequence number, means R1 LSA, which is having the sequence number of what? 1000, the new one. Previous one was 999. This is the database of R4. And what is going to happen, guys? Let me choose maybe the red pen here. R3 is going to advertise the same LSA, R1 LSA towards R4. So it means that now consider the fact that R4 is getting the same LSA with the sequence number 1000 from R1, and it is getting the same LSA with sequence number 1000, because this is a new LSA, from R3. Which to believe? This is interesting, right? But now we can say that if the sequence number is same, then both the LSAs are exactly same. But yes, these are received at a different time, because R4 is nearer to R1. So R4 is going to install this 1000 and just flush out the 999 sequence number LSA from its database. But now R3 is again sending the LSA with the same number, because our R3 is getting the 1000 from R2 and now it is forwarding towards R4. It means that R4 is getting the same sequence number from two places, R1 and R3. And this is the LSA, guys. This is the information. This is not the routing update that you need to come to me. So which is more recent, or which information to believe? These two information, guys, are exactly same, right? Because the sequence number is same, and the sequence number is same, then basically R4 is going to say, I already have installed the LSA with sequence number 1000 in my database. I do not need more, so it is going to drop this LSA information. It is not going to change its database because in its database the packet was already there. It is as simple as that, right? So on the basis of sequence number, we are deciding what information. I could see the hand raise. Do not worry, guys. I'll come to you and I'll take a pause. Let me complete the concept of sequence number and the aging, and then we are going to start discussing your questions also. So do not worry about it. Till now, you just try to understand that we have sequence number now, and the router which is creating that particular LSA is the only router which can increase its sequence number. Nobody else can do that. And this is quite logical also, right? Because this piece of documentation, which is R1 LSA, right? Who has created that? Of course, R1. What other routers were doing? They were just forwarding it. They were included it. They were taking that LSA, right? And they were storing them into its database, and then they just flood towards its neighbor. It is as simple as that, right? But if there is a change in this LSA, who is responsible for generating that change? Only this router, R1, right? So only router which can change the sequence number of the LSA is the one who have actually created that LSA at the first place. So if there is a change in the link in the R1 LSA, then basically R1 is going to change the sequence number by 1. It is as simple as that. So you keep this thing in mind because it's quite logical. If I have created that, how can R3 is going to change it, right? If R3 change that, then it's a problem. If the LSA of R1 is going to be changed by R3, it is a problem, right? Because R1 has created it. R1 knows better than R3 what has changed on this router. It is as simple as that, right? But this approach has one major issue, and we need to understand that issue, right? Because these sequence numbers which we are taking, right? What is going to happen if these sequence numbers are, if the sequence number has reached to its maximum limit? What is the meaning of maximum limit, right? Suppose we are choosing the sequence number from a range, and that range is from 0 to 9,999. Suppose. It is very interesting, right? So we are starting from 0 and then we will go till 9,999. So this is my lower limit and this is my upper limit of what? This is my lower and upper limit of sequence number. It means that when this R1 generating the first LSA, maybe it is going to start from 0. It is as simple as that, right? But what is going to happen if there is a change? If this guy is changing the links, maybe it is shutting and unshutting them. If that is the case, then this R1 is going to again generate the LSA. And it is in the process, it is going to do what it is going to do is it is going to change the LSA sequence number from 0 to 1. Then basically there is again change, then from 1 to 2, 2 to 3. And you can understand, because this sequence number are finite, we are going to reach at 9999, right? If we reach this 99999, then what is the problem we are going to face? Just try to understand. Suppose we have moved from 0 to 1, 1 to 2, 2 to 3, and now we have this R1 has generated the LSA. Means somebody is changing, somebody is doing all these changes these much of time. So R1 is generating the LSA, suppose with this value 9999. Let's leave the concept of age for now. Suppose, right? And now R2's database has installed the R1 LSA with the sequence number which is 99999, right? And of course, everybody, because this is going to be flooded across, so everybody's database table, this R1 is going to have sequence number of 9999. And here is my problem. Suppose this guy is still there and it is again changing the state of this link 3. And if it is changing the state of this link 3, it is not going to be here. The new LSA is going to generate it. What should be the sequence number of this new LSA? You can say that, okay, if the number is exhausted, then let's move towards the first one. If we cannot write 10,000 because the state because we haven't included that in the sequence number space, then we need to move back from 9999 to 0. And suppose this is the strategy which is OSPF using. So now what is going to happen, guys? R1, there is a change, then it is going to replace this LSA with the new sequence number which is going to be 0. Interesting, right? Now LSA, another LSA is going with, which is same R1 LSA, but this time the sequence number was not 9999. The sequence number is going to be 0. Similarly here also, because R1 is going to sync only with its neighbor, it is going to send across this change with sequence number 0, right? Interesting. Now what is going to happen? R2 is having the same sequence, it is having the same LSA into its database. R4 is going to have the same LSA into its database, right, with a sequence number 9999. And now we are going to get the new sequence number, which is R1 LSA with a sequence number of 0. Which one to believe? And you all know about it. The higher the sequence number, the more recent the LSA is, right? Previously, that was the strategy which you are following. So suppose if I have a sequence number LSA which is 2, and now if I get anything which is greater than 2, which is 3, then I have to believe this one, right? Now try to understand. We have 9999 sequence number of LSA of R1, and now I'm getting another sequence number which is generated by R1. Which one to believe? Of course, the information in LSA with the sequence number 0 is more recent. But now this router is going to understand that I have the higher sequence number, and that is why I do not include this LSA into my routing table. I'm not going to flush out the 9999 because it has the more recent sequence number. But my problem was I cannot go above 99999, and that is why I was using 0. So this approach is going to be failed. It means that apart from sequence number, we should include one more concept. Because sequence number were working pretty fine. If I get a sequence number which is higher than my existing LSA, just replace that LSA with the higher sequence number, because the higher sequence number is having the more recent information. But in this case, the lower one was having the recent information in a specific case, in a corner case scenario. And if that is the case, then what is going to happen? That is where we are going to need aging to know about which one is recent or which one to believe, right? On the basis of aging, we can decide, and you all see this in the real life, right? If a person is having the age of 36 years maybe, and the other person is having age of 32 years, you understand that 36 is actually the old one and 32 is the new one. Or I can say that 36 is the older, right? It is as simple as that. So how we are coming on this concept of aging, you know that all those sequence number were performing pretty well. There were no problem with respect to them. But now in a corner case scenario, this is going to be failed. And by the way, guys, we call this sequence number space, whatever we are using, from 0 to 999. And then when we move back again to 0, it is kind of a circular sequence number, right? Which OSPF use. And that is why there is another concept. The concept name is aging. And you know that why we are including another concept, because sequence number was not serving well in a specific scenario, right? So let's